a vector can be represented in two different ways. Suppose so first method to represent a vector is symbolic representation. Symbolic representation is used when you are reading a paragraph, when you are reading a material, and during the reading you met with different types of symbols. Then how would you differentiate between a vector and other quantities? Suppose you have number of elements. Okay, suppose you have these quantities, like these are the symbolic representation of different quantities. Then how would you differentiate between them, among them, that which quantity is a scalar quantity and which quantity is not a scalar quantity? The quantity which is a scalar quantity would have a bold letter. It would be little bold as compared to others. Suppose D is a vector quantity, then it would be comparatively bold. So if any symbol is comparatively more fatty than others, it means that is a that is a vector quantity. Okay, next thing is, if there is a line on any alphabet like this, or any line below an alphabet, that is another representation of a vector quantity. In some cases, there is an arrow. If any symbol have an arrow on it, or have arrow below it, then it is also a vector quantity. So first representation is that it may be a bold letter. If a letter is comparatively bold, then it would be a vector quantity. If we have an arrow on it, if there is an arrow on it, or there is an arrow, like in physics we use arrow on any on any letter, but this is the representation for maths. This is for physics, this is for maths. In case of maths, there is a the representation is quite like this, but in physics we put arrow on any letter. That is actually the representation of vector quantity. Second thing is the graphical method. Suppose we have a graph of different quantities, then how would you differentiate that this is for this graph is for scalar quantity or vector quantity? Then suppose you are saying that 5 Newton force acts on an object. Simple. 5 Newton is the 5 Newton force, and it is acting in eastward direction or northeast, or you can say southwest. Southwest is the direction. So 5 Newton is the force and southwest is its direction, because force is a vector quantity. Then how would you represent it? Suppose this is our coordinate axis, or you can say map. Here is north, south, this is west, and this is east. Okay, so southwest, and here is a southwest. Okay, suppose southwest, 5 Newton force is acting in southwest. Southwest, suppose, is like this. This is the 5 Newton. Okay, the length of this quantity, the length of the length of this line is the magnitude of vector quantity, and there would be an arrowhead that actually represent the direction. So this arrow is in representing the direction, and the length of this arrow is the magnitude of this vector quantity. It can be in other direction, suppose northeast direction, northwest direction, like this. Northwest direction, it may be in west north direction, northeast, east direction, southeast, whatever. Okay, so you can see the direction is actually the direction, like this arrow is actually the discriminating element. This arrow actually discriminate between a vector and a non-vector quantity. Suppose here is simple a line. This line may be a scalar quantity, and this arrow-headed line, this arrow-headed thing is a vector quantity. So this is how you differentiate between them.